inside the house, you know, that's fine. It's not going to end poorly at all.
Nah, there's no fire danger.
All right. I'll be over here.
Not like this game calculates that or anything.
Yeah, no, it's fine. All right, guys. You guys gotta log out because I'm the host and I'm gonna pull the host.
I'm out.
All right, cool. Thanks for playing with me, guys. I'll talk to you later. I'm gonna take a break.
Yeah,
and
it was
move to
fun.
Space news. All right, see ya.
Later, man.
All right, guys. We'll start Space news now. Let me just get a second. We'll basically start it at 5, and we'll go from there. We kind of have to shorten Space News today. I want to get the SSDO going because we have an Ariane launch at 9, so it's gonna be quick. We're gonna, like, at 6 o'clock basically we'll start KSP and we'll go from there. So I hope you enjoyed some Icarus early hours. I'll switch us over to Science and Technology and we'll go from there. All right, I'll be back in a moment. watch We Deliver, at least the beginning, to start space news. Is that fine? We need the We Deliver. We Deliver. This is important for science. Oh, audio's bad. Try this one. Dual channel? Dual channel?
Okay, and the port restraint is out. Here comes the spin. Here it goes.
Yeah, we see it down here, Bill. It's beautiful.
Okay, Mike, we're at 52, coming back down to 51 RPM.
Roger, we copy. You guys look good. And Columbia, Houston, everyone down here is go for deploy with 2 minutes left over Hawaii.
And so is everyone up here.
Roger, we copy.
Mike, we hope the TV comes out. It doesn't play back very well on a monitor, but we're relatively sure we got it. And we, by the way, still have that beautiful satellite inside. It's traveling just below it.
Roger, we copy, Bill and Joe, and got a lot of happy people down here. You guys did good work.
Okay, Mike, we delivered. We got SBS off on time. And if you're interested, I'll read you the pad.
Roger, go ahead.
Deliver the crew of Shuttle Mission 5 did. Only 8 hours into the first operational flight of the Space Shuttle program. 5th flight of the orbiter Columbia. The first 4 missions were test flights to prove the space transportation system could provide access to low Earth orbit on a routine basis. Those missions laid the groundwork for the operational era. Shuttle Flight 5 was the beginning of that era. The primary purpose of the mission, to carry 2 communication satellites into orbit, deploy them from the payload bay, then return to Earth.
Columbia, Houston, 30 seconds till LOS, and everything is still go down here for deploy.
Roger, Brian, we copy that. Thank you very much. We're looking forward to having a good one.
Roger, and good luck.
Okay, Houston, this is Columbia. We are 2 for 2. We deliver. Hey, Roy, are we down now? That was, are we on the ground?
Absolutely.
A flawless landing. Only minutes after sunrise at Edwards Air Force Base, California, ended Columbia's 5th mission. Looking slightly weathered, the orbiter had traveled over 10.5 million miles in 5 flights, spent 24 days on orbit, and circled the Earth almost 400 times. It would now return to Kennedy Space Center, Florida, for refurbishment, to be launched again on Shuttle Flight 9.
In the early days of our republic, Americans watched Yankee clippers glide across the many oceans of the world, manned by proud and energetic individuals, showing our flag breaking records for time and distance, opening up new vistas of commerce and communications. Well, today, I think you have helped recreate the anticipation and excitement felt in those home ports as those gallant ships were spotted on the horizon heading in after a long voyage. The fourth landing of the Columbia is the historical equivalent to the driving of the Golden Spike, which completed the first transcontinental railroad. It marks our entrance into a new era. The test flights are over. The groundwork has been laid. And now we will move forward to capitalize on the tremendous potential offered by the ultimate frontier of space.
When thousands of civilians began pouring onto a military base, located on a desert, in the middle of summer, early on a Sunday morning, one could sense the day's events were going to be special. Spectators came to Edwards Air Force Base from all over the nation and all walks of life to celebrate the nation's 206th anniversary of independence and witness historical events more spectacular than the typical 4th of July fireworks display could ever hope to equal. The fourth landing of Space Shuttle Columbia, world's first reusable spacecraft. Columbia's first landing on a concrete runway, officially ending the orbital flight test program. Takeoff of the second orbiter in the shuttle fleet, Challenger, on its ferry flight to Kennedy Space Center, Florida, to be launched into space in the early part of 1983. And with Shuttle Pathfinder Enterprise as backdrop, the announcement of America's new space policy by President Ronald Reagan.
Beginning with the next flight, the Columbia and her sister ships will be fully operational, ready to provide economical and routine access to space for scientific exploration, commercial ventures, and for tasks related to the national security. Simultaneously, we must look aggressively to the future by demonstrating the potential of the shuttle and establishing a more permanent presence in space. Our goals for space are ambitious yet achievable. We've only peered over the edge of our accomplishment.
Surely, our accomplishments began with Columbia's first launch in April 1981.
Main engine start. We have main engine start.
Roll program. Go. Roger, roll. Roll program complete. Roger, roll complete.
Looking back at that spectacular event and the performance of Space Shuttle during its first 4 flights, there seems little doubt now that it is a reliable, reusable space transportation system. When Columbia first arrived at Kennedy Space Center in March of 1979, there was some skepticism. 2 factors were leading to major delays in the launch schedule. The quest to advance the state-of-the-art in space technology, particularly in engine design and thermal protection, plus budgetary limitations imposed on development and testing of shuttle systems. With 2/3 of shuttle's tiles already on the vehicle, it was discovered that the bond was not strong enough to keep the tiles from falling off during high-stress phases of flight. The fix, called densification, required that most of the tiles be taken off, coated with a material to increase the bonding strength, then reapplied to the vehicle. The process took over 1 year to complete, but it worked. During the orbital flight test program, only undensified tiles showed weakness along their attach points on non-critical areas of the vehicle. Shuttle's main engines achieved the state-of-the-art in rocket engine technology. But as with any research and development program, confidence in the design came only after years of testing, learning, and some mistakes.
Oops.
Problems encountered during development of the engines were related to the unique requirements that had to be met. Reusability, up to 55 flights with minimum maintenance. Ability to throttle down to 65%. Lightweight, yet the capability to withstand extremely high chamber pressure. Pressure needed to generate the thrust or liftoff. Many failures that occurred were due to the tremendous pressures and vibration levels created trying to produce the needed thrust.
Oh, and it broke. Yep. Yeah, that's not fun.
But one by one, the problems were solved. The design was proven long before the first launch.
Go for auto sequence start. Break is closed.
Go for main engine start.
4, we've gone for main engine start. We have
Hey, Monica.
Columbia was launched. Again. And again. And again.
Fly, baby, fly.
4 times within 15 months, traveling over 8 million miles during the first 4 flights. "314 revolutions around the Earth. 19 days on orbit."
Oh, that's so cool.
But beyond the statistics, a far more important goal was achieved with completion of the orbital flight test program. The foundation for our future was built, step by step, mission by mission.
You guys want to finish this? It's a great documentary. Yeah, picture the payload bay door open. It's pretty cool. Yeah? Alright. Remember, if there's more space news that we need to cover, there is some Russian stuff that I want to cover today. But if there's more space news that we need to cover, the Ariane launch is at 9, so we'll cover that. Between the launch and Friday night racing, we can do more space news. This is space news, but it's space news from 30 years ago. But it's space news. Yeah, it's fine.
The goal of STS-1 was, quite simply, to get up and get down safely.
Columbia, Houston,
it is
you guys did so good, we're going to let you stay up there for a couple of days. Your goal for on orbit.
When astronauts John Young and Robert Crippen heard that announcement, they knew the mission was at least half a success. When returning from space, friction created by entering Earth's atmosphere blocks communication between mission control and the astronauts for 15 to 20 minutes. But it is also precisely during that time that temperatures on the vehicle surface reach their peak and shuttle structure undergoes its most stringent test. On Columbia's first flight, no one could predict exactly how shuttle would perform during that phase.
Yeah.
Hello there. Houston, Columbia's here.
Hello, Columbia. Houston's here. How do you read?
Plan clear, and we're doing Mach 10.
With voice contact reestablished, spacecraft and crew had safely passed through the most critical phase of entry. Landing was the final test.
Right on right slope.
Flown as a glider, Columbia landed without power on the first and only attempt.
You're coming.
You're down.
You're down. 50 feet. 40. 30. 20. 10. 5. 3. 2. 1. Touchdown. There's gear. 10 feet.
They're around on YouTube, Alcom. I can give you
5. 4. 3. Touchdown. Houston, Columbia's on the roll.
Welcome home, Columbia. Beautiful, beautiful.
Columbia's second flight was the first opportunity to evaluate the Canadian-built remote manipulator system. Manual functions were tested by astronauts Joe Engel and Richard Truly. Automatic functions were computer-controlled. The arm performed successfully in all operating modes. Preliminary thermal tests of the vehicle were also begun on Flight 2. One thermal attitude resulted in the payload bay being pointed toward Earth for extended periods of time. During those periods, a package of 5 Earth-viewing instruments, designated OSTA-1, was activated. The package, composed of low-cost commercial-grade sensors previously flown only on aircraft, and instruments flown on individual satellites or past manned missions, collected the first Earth resource data using shuttle. The ability to mount all 3 types on Columbia greatly reduced the expense of acquiring the data.
You want to join? Okay. 100.
Look at that thing.
50. 30. 20. 10. 5. 3. Touchdown. Nose gear 15.
It's so cool.
10. 10. 5. 3. Touchdown. Welcome home. Thank you, Chase.
Flight 2 proved shuttle was truly a reusable space transportation system. Third flight of Columbia was primarily a thermal test of the vehicle, exposing it to the most extreme temperature differentials it could encounter on orbit during upcoming operational flights. No facility on Earth could simulate the same heating conditions Columbia would experience in the vacuum of space, where temperatures could vary greatly from one end of the orbiter to the other, depending on its orientation to the sun. The thermal tests determined precisely what effect different attitudes had on shuttle structure. The vehicle suffered no adverse effects. Evaluation of the remote manipulator system continued on Flight 3. Astronauts Jack Lousma and Gordon Fullerton tested the system's payload handling capability. First order of business was unberthing. Although clearance around the payload was only 2 inches, Fullerton unberthed in just 5 minutes. much quicker than had been predicted pre-flight. Using the plasma diagnostics package, 7 computer-controlled automatic movements of the arm were evaluated to prove scientific instruments could be maneuvered in and around the payload bay.
Only some general comments on the arm operation. The operation is smooth. There's definitely a little bit of flex and dynamics, but in the augmented modes, that's very minimized. Really no surprises. If there are any surprises, they're all pleasant. I'm really impressed with that piece of machinery.
Hey, that's great news, and we were impressed too.
The plasma diagnostic package was one of 10 instruments making up a scientific package on Flight 3 called OSS-1. Shuttle's movement through the ionosphere, electrical buildup on surfaces as it circled Earth, and electromagnetic interference between the ionosphere and electronic equipment on board were evaluated by the OSS-1 instruments to ensure that these phenomena would not adversely affect scientific instruments or sensitive astronomy observations on future shuttle flights. On Flight 4, the Induced Environment Contamination Monitor was used to check for contamination in and around the payload bay, created by thruster firings, outgassings, and water dumps. 11 separate components of Shuttle's induced environment were measured. The desk-sized monitor was the heaviest payload lifted by the remote manipulator system during the orbital flight test program. Thermal tests on the vehicle were completed during Flight 4. The first Department of Defense payload was on board. The spacesuit to be used for extravehicular activity on Flight 5 was tried on during Flight 4 to practice the procedure.
Still use those things today. Not that
And
exact
astronauts
suit, but
T.K. Mattingly and Henry Hartsfield conducted a thorough evaluation of on-orbit procedures for the upcoming operational era of spaceflight, when Columbia will launch into Earth orbit on a routine basis. An ongoing task on all 4 missions of the flight test program was to evaluate living conditions.
Or the audio could just, go away. Note that they have ejector seats. Even on Flight 4, the shuttle carried ejector seats up until then, and then on Flight 5, they took them away. They took them away to increase payload mass a little bit, because, the ejector seats are pretty much useless past, 40 seconds. Yeah, they'll kill you. Yeah, you're too high. That's how fast the shuttle gets out of the atmosphere. Those SRBs really get up and go. You guys will see it in February. This is all great and stuff, but NASA's own words, we have never been able to get out of low Earth orbit. Nah, Ray, NASA never said that. And if they did say it, you probably didn't. You probably heard it in the incorrect context. It's almost like this stuff is complicated, and contextualization very much matters in the confines of aerospace engineering. So you probably heard wrong, to be completely honest.
So appraised. Very busy schedules are forecast for upcoming shuttle flights, when crews will be comprised of at least 4 people, including women. Procedures on the ground are being streamlined for the operational era. Processing time was cut in half during the orbital flight test program. Presently, it takes approximately 13 weeks to prepare the space transportation system for launch. It is projected that by the mid-'80s, there will be 2 shuttle launches per month. The number of people in mission control is gradually being reduced. Some positions have been eliminated. Others have been consolidated, which represents a clear indication of confidence in Columbia's systems. While this monitoring is being streamlined, payload monitoring is increasing. A new area called the Payload Operations Control Center was activated during the orbital flight test program to give mission controllers,
sometime in the 90s, Jim,
payload managers, and commercial users the opportunity to develop monitoring and data acquisition procedures for upcoming flights.
They really wanted that reusability. The shuttle could have done it, Alex. The shuttle could have done it. Oh yeah, the shuttle's a great design. Sorry, no one's gonna change my mind on that. It's a good design. It could have been reusable. It could have been reusable. You could have refined the design enough. You could have refined the design enough to make it safe enough. It would have been. Yeah, you could have done that. I've spent years reading and understanding how the shuttle systems work. The amount of the amount of processing, anything from like using a Slick 6 style pad as opposed to a 39A style pad. Yeah, the shuttle could have been done. I mean, in 1985, dude, they launched a shuttle 9 times. In 1986, Challenger happened on January 28th, 1986, which, is a terrible day. Sad day. There had already been 1 shuttle flight that year already. Yeah. 1986 was the year they were going to nail that 2 flights a month mark, and they were basically scaling to do it. It was only a matter of time. But it was also only a matter of time before some dingbat said launch it in the cold. Which brings me, and this is where we'll pivot off of this, okay? Which brings me to the next thing. The reason why the shuttle ended up having so many problems is because they did not give it the development money that it needed. They were trying to build a Mercedes with Honda dollars here, okay? It's not, now, I'm not saying that Honda's a bad car, but I don't think there's any Honda ever sold ever, maybe save for like an NSX, that, goes for the price tag of like an S550 AMG Mercedes, which is a really nice car. You can't tell them to build the most complicated piece of equipment around and skimp on the testing, which is basically what happened. I mean, guys, the RS-25 engines, the Space Shuttle main engines were initially baselined with 55 flights with no refurbishment. The realistic expectation ended up being one flight. Then you have to take it apart and put it back together, like a pro stock engine on a dragster. They missed the mark, like, big time, and that really came from lack of testing. There was this. The testing wasn't substantial enough. We don't have the budget to test. The shuttle remote control. We have to put people on it. Nice, Alleviate. The ridiculous mission requirements from all the different branches didn't help either. That was the only way NASA could do it, is with DoD money. I even say with the DoD changes into the design, it's still good. Shuttle's still fine. You're telling me that you couldn't come up with a way to prevent ice from accumulating on that external tank? Like, New Shepard is a Hydrolox rocket. That doesn't have ice accumulate on the sides. Now, granted, that's a lot newer technology comparatively, right? Like, You telling me that we couldn't have figured out a way to do that, to insulate hydrogen sufficiently? I'll tell you. I'll talk about that in a second, Restaurant. Isn't the NASA budget like $54 million a day? I don't know, Ray off the top of my head. It's about $20 billion a year, so I don't think $54 million a day is entirely right. But you got to remember, dude, that's not just building rockets. That's everything. Every single freaking thing that NASA does, from monitoring the climate to the Perseverance rovers, Curiosity rovers, building rockets, all the systems associated with building something like this. That's everything. Total cost involved. Look at that thing. Look at that freaking thing. It's going to be special when that thing flies, man. And we're not that far away from it either. Yep. That includes everything. And NASA has to be super transparent about its pricing structure because they're using taxpayer dollars. So they actually tell everything total cost involved, which is why we know that in the first place. Super big form of transparency, which I generally just really appreciate. Rollout's gonna be amazing. We're looking at a late November, early December rollout, Jim, and NASA had a press meeting this morning about what the current plans are. Good news and bad news. The good news is that the stack is fully integrated. You have a full moon rocket ready to go, or at least as close as we're going to get for right now. The bad news is that it's not going to, they're targeting February of 2022. It's not going to launch this year. However, that's not a bad thing. At this particular point in time, a 1 to 2 month delay is not a big deal. That's not a big deal. We're in the home stretch. Take all the time that you need. Remember when I said a second ago with the shuttle program that it pays to do your homework now so you don't encounter problems during operational missions? There you go. Now, with that being said, I'm a little bummed that it's not 2021, but the roadmap to that February 2022 launch is concrete. The schedule is starting to solidify, which is very good. It's not like, oh, it's going to be in February 2022 because, we don't know how long it's going to take to fix this problem. Or we don't know how we encountered something that we don't understand, et cetera, et cetera. It's not that. We have to do a wet dress rehearsal. We have to do tanking operations. We have to analyze the data from that, make sure that the data matches up with the math, and then we'll get ready to launch. The Artemis 1 mission also is constricted by certain times when it can and can't get to the moon. The type of orbit that it's trying to get to, a distant retrograde orbit, has a launch window similar to going to the ISS. We're now, it's something that a lot of you guys haven't really, the newer space fans in here haven't really had to deal with this problem, and you don't deal with this problem in Kerbal either. Now you have to worry about phasing. Phasing is a big deal. The moon has to be in the right spot. You can't launch the dang rocket, right, and then burn for the moon and have it not be there. So this is subject to very specific launch windows to get the Orion capsule where it needs to go. So that's the reason why they're targeting February. Like I said, they're targeting February because they could probably make the late January window, but it would be too close. And if something, if it scrubs, it's going to be scrubbed for a month anyway, or not a month, a couple of weeks till it gets to the next opportune time where the moon is close enough for the Orion capsule to get into the type of orbit it's going to get into around the moon. So, like I said, 2022, February 2022, so we're still about 4 months out, but we have a solid roadmap for the first time that I can remember. We have a pretty solid roadmap to launch from where we are now to the launch window. So that's it's bad that it sucks that it's getting delayed 2 months, but right now, finish everything, cross the T's, dot the I's. We don't want to have so to speak, an O-ring failure or something. You don't want to have those problems manifest themselves now. Bad idea. Let's not do that. Off topic, but you will like this. Oh, look. 2 race car teams that I don't care about. Nice. Why are they racing on... Okay. Oh, that's cool. Anyway. We lost the November launch. John, they did the umbilical test from a couple of I think a month ago. They did the umbilical test and they ran into some things for the umbilical test. Okay, here, let me go down past before all the Route 154 stuff. When they did these tests, they encountered a failure mode on one of the umbilical, one of the core stage umbilicals. Now, this wasn't a surprise, believe it or not. The umbilical testing site that they have to basically make sure that all the umbilicals work is down the street at Kennedy Space Center's Industrial Park. It's down, well, not the Industrial Park. It's at KSC proper, so it's not at the VAB. It's at, like, KSC headquarters near the ONC building. The Launcher Umbilical Test Facility, or I think, yeah, LUTF or LETF, I think it's called, tested one of these umbilicals, and they during one of their tests, they ran into a failure mode with it that can wear some of the components down on the umbilical. I'm not sure if it's exactly that one. It's the CITSU, so core stage inner tank service umbilical. So it's not that one. That's the core stage forward skirt umbilical. It's the one that's below it. They ran into some problems, and when they went to run this test here on the actual thing, they duplicated the circumstances for separation of the umbilical, and it did the exact same thing, that's a good thing. Both of the systems failed. That shows that both of these systems did the exact same thing, and they did exactly what they were expecting it to do. No surprises. You don't want any surprises, even if that means separating the umbilical knowing that it's going to break. So they ran into a little bit of a problem with that, and they're fixing it now, amongst other things. There's just a couple of small things to button up. That's something that you couldn't have tested until now. They can separate the umbilical all they want at the testing facility down the street. They can separate it 1,000 times and get the same result. But you're never going to know if that's exactly what's going to happen because you don't have an SLS rocket to attach it to test those circumstances again. Now that they have the rocket there, they tested it while obviously the rocket was in a safe state. They tested separating the umbilical, and it did the exact same thing that it did on the test stand, which is good. That's a good thing, even though it failed. It failed, but they were expecting it to. So that's good. That's what you want. You want your results to be concurrent, right? So there's a couple of small things here and there that they need to button up. That's one of them. Couple of things here and there. They should be good for a wet dress rehearsal sometime next month. So we should see this thing roll out in 2 to 3, 4 weeks, maybe at the latest. It'll roll out to the pad in December. They'll start testing all the equipment on the pad, and that'll lead up to a wet dress rehearsal where they tank the rocket, they fuel it up, they run through the countdown procedure, and they basically do everything. And then at T-minus 10 seconds, they hit the stop button. They'll detank the vehicle, send it back to the VAB, do final checkouts, make sure nothing got broken during the wet dress rehearsal, and then it's time to go. So which one is the hydrogen umbilical? There's no hydrogen. Okay, so liquid hydrogen or gaseous hydrogen. Task failed successfully, quite literally. There's no hydrogen umbilical. There's the core intertank service umbilical, which is down here. It's on the intertank on this rocket, which is right in this area here. The CITSU is designed to get gaseous hydrogen, away from the vehicle. Gas is on the top of the tank. liquid from the bottom. These two things right here that are like this, that are bent inwards, those are the fueling umbilicals for SLS. This one over here is your liquid hydrogen tail service mast umbilical, and this one is the LOX tail service mast umbilical. Those are people-sized doors, by the way, if you want the scale of these things. They're about as tall as a 3-story building. They house the fueling umbilicals for SLS. Hydrogen on the left, oxidizer on the right. Just like the shuttle, believe it or not. The LOX umbilical splits well, it tees in, right? And there's there's 2 pipes that go up, and there's 4 pipes that go down. The 4 pipes that go down go to the 4 engines. The 2 pipes that go up go to the 2 downcomers. These things, there's 2 pipes on either side of SLS to feed 2 of the engines liquid oxygen. They'll start plumbing the fuel in, and when they go for fueling operations, the LOX will go up the pipe and into the tank up here. On top of that, from this picture right here, that's the core stage forward skirt service umbilical right there. That one has gaseous oxygen coming out of it, and that's what that umbilical is right there. That thing is pulling gaseous oxygen away from the vehicle. So there's no hydrogen or oxygen umbilicals. There's gaseous hydrogen and gaseous oxygen umbilicals. In spaceflight, that's called HAZGAS, hazardous gases. At least that's what it was called during the shuttle. It could still be the same thing for SLS, I'm not sure. And then there's your liquid fuel umbilicals, or TSMUs, tail service mast umbilicals, which are down at the bottom. So either way, it's a fully stacked rocket. That's going to look amazing. I kind of want to see it roll out of the VAB. Is the oxygen being repurposed or just vented away from the vehicle? Just vented. Actually, in this picture, it's not fully attached. It's close. So you could still see the service propulsion system engine right there. But that's about as complete of a picture that I've seen here. The rocket is 322 feet tall, or about the equivalent of a 32-story building. So next time you're in a city and you look at a building, find one that's 30 stories tall. That's how big that thing is. Just the rocket. That's not including the launcher. Which is unbelievable. It's crazy. Crazy. Do we know who will land on the moon first? I'm not sure what you mean, but... New lift and mate footage. Okay, we can check that stuff out, but also here. Let's see what else we got. Oh, man. Okay. Dude, it's just eye candy. There's so much contrast going on inside of the VAB. It's just freaking eye candy. And yes, those are hardwood floors, in case anybody's wondering. You know why? Because you have fully fueled solid rocket boosters down there. You don't need a static discharge. Yeah, wood doesn't conduct electricity, so they got some nice hardwood floors there. Can you imagine? Just your desk, your office being up here. This is like 300 feet above the ground. Whatever. Imagine just having your desk right here. Yeah, that's my desk. My city doesn't have a 32-story building. Yeah, that's crazy, right? Don't drop your pen. Yeah, it's a long way to go and get it. Oh, these pictures are beautiful. Isn't the VAB considered a one-story building? I don't think so. I've never heard anybody say that before, Sumo, but I do understand kind of what you're getting at there. Oh my gosh. I would pay a good deal of money to walk right here. My apartment block is 7 stories high and it looks huge to you. Yeah. M&M stack 4 of your apartment building on top of each other, and that 4 of your apartment building is like right here. The VAB, dude, because Florida is so flat, you can see it miles away. You can see it even with a high-powered telescope in a tall enough building. You can see it clearly from Orlando. It's kind of crazy. Orlando's 50 miles away. That's 80 kilometers. Are they going to do a NASA social for this? You should definitely apply. Yeah, I mean it probably will. I don't want to do a social. I want the press pass. I got to figure out how to do that. Could Starship fit inside the VAB? Yeah. Yeah, sure. Starship is not much taller than this thing. Man, that's crazy. It's so cool to see a moon rocket in here again. This is the first time any rocket's been stacked inside of the VAB since STS-135 in, like, April, March of 2011. It's been 10 frigging years. Oh, look at that thing. Yeah, Matt, 2011. Look at that. Look at that monster. Oh, my goodness. Hey, also, yeah, we kind of covered this a little bit yesterday, but the pressure vessel for Artemis 3 is already at Kennedy Space Center. They're building the Orion capsules in the Neil Armstrong Operations and Checkout Building. So that's called O&C for short. O&C, Operations and Checkout, is where they're putting these things together. The third Orion capsule is there. And the second one is being built a little ways over there as well. How about Ares 1X? Ares 1X was in 2009. Awesome rocket, if I do say so myself. Yeah, and, you know, Thomas, we've been footing the bill since, which is just annoying. The ESA box is the service module for Artemis 3? Negative. That's the service module for 2. Service module for 3 isn't finished yet. The pressure vessel for the capsule is, though. Yep, there it is. There's the service module. Anything launching this week? Actually, there's an Ariane 5 launch in about 3 hours. Sun Temple. So yeah, of course, there's always something launching. Question is, are they streaming it at this point? But anyway, where's the vidya? New lift and mate footage. Let's take a look here. Ariane 5 got scrubbed. Alright, cool. That'll make more time for KSP anyway. That actually helps me a little bit. Ariane 5 has no new date. Oof. There's the crew access arm right there. Don't drop that stuff. Don't drop it. Careful. Wait, is James Webb's date in trouble if Ariane is going to get pushed? Not sure. What, did they drop it? No, it's a joke. Link to this vid. Hell Hydra, could you link that up again, please? Ariane 5 is now scheduled for the 25th. There you go. Thanks, buddy. How do most satellites get to space? With a rocket. Okay, just line it up. There we go. Now they're lining it up with the pilot dowels like I was telling you guys. Oh, man. Look at that thing. No, they use hopes and dreams, Matt. That's crazy. What about big balloons, weather balloons? Weather balloons on a good day can get up to 100,000 feet. Ray. On a good day. You need something to be 380,000 feet to be in a nice stable orbit, going 17,500 miles an hour. A weather balloon isn't going to do that for you. That will, though. Like I said, guys, this is about 300 feet up in the air. The ground is down there, about 30 stories that way. That's how big this building is. I wish they could, it'd be cool if they could take the camera and just kind of point down here. You'd see what I was talking about. Man, that footage is insane. Okay, it's Vissel. I need a time machine. This capsule doesn't beat the wings. What are you saying? You like the space shuttle? Cool. Anyway, that's the big stuff, dudes. SLS is ready to go, man. We're like this close. I hope that NASA gets a fire under its tail. So the other thing that I was thinking, or not thinking, the other thing that I noticed is, and this is just from people linking stuff in chat, I've noticed that it seems like Bill Nelson is making a lot of moves kind of without really talking about them. From what I understand, the contract for the second mobile launcher was reorganized, and the plan was to build the second ML in sub-assemblies at Port Canaveral, and somebody at NASA just said, that's stupid. How about we build it where we're going to use it? So they renegotiated or changed the contract for the mobile launcher. They didn't change the contractor. They said, how about you build it where we've built every other mobile launcher in the past? Yeah, that would probably make a lot of sense, huh? Did NASA manage to get any money in the earlier $750 billion bill or the new $1.5 billion one? I'm not sure, King. I'd have to go look. After the first flight, they have to pray they don't cancel it. It's not going anywhere, Bandit. I'm not worried about that. No, Hip. It's not going to be 2021. February 2022 is pretty much the net right now. And that's, believe it or not, that's not because of any particular thing. I just said a second ago they were having some problems with the umbilicals. But it was a known thing. They just got to fix it. They're having a couple of things here and there that they need to button up, couple of things to close out, and that will push it out of the December window. And maybe even into the January window, but it seems very much like you can't just say, oh yeah, okay, so they're going to launch in January. There's only certain days in January that they can launch because the moon has to be in the right spot. Remember, we have a phasing problem now. Fortunately, the moon doesn't go very far away, but it does have to be in the right spot. You have to insert into the correct inclined orbit at a KSC. And then you have to do translunar injection at the right time because you're in an inclined orbit. It's not like Kerbal, where the moon is just on the equator. Our moon's 6 degrees inclined relative to Earth's equator, and Earth is 27 degrees or 21 degrees tilted relative. Our planet is tilted relative to the solar equator, right? So if the sun's equator is here, Earth's equator is like this. And then the moon is 6 degrees inclined off on top of that. So there is a pretty hardcore phasing window here. So where they're basically at right now is, you know, if everything goes right, they'll make the end of January 2022. But there are more opportunities, and because, you know, you can't be 100% sure that everything else in the testing regime is going to go exactly right, so they're targeting the end of February because that's when the next good window is, at the last week. I think it's the last week and a half of February. So said ML thing, there you go. So it's gonna take a second, but we have a concrete roadmap to launch now, which is pretty damn good. I like the transparency. NASA had a press meeting this morning about Artemis 1 progress, and that's basically what's going on. Not to kick a hornet's nest in chat, but is Eric Berger justified about that article a month or so ago about it being delayed until next year? Yeah, I would say, yeah, he got that right. Sure. Yeah, I mean, yeah, yeah, I would say that's about right. But once again, he said, somebody told me that SLS is going to launch in February 2022. Like, what are you supposed to do with that? But yeah, he just said a source says. That's my thing, dude. Look, I'm not just trying to communicate like what NASA's doing, all right? I'm trying to show you guys how the process works. Going off a whim or going off an opinion or saying you have no evidence doesn't really work with engineering. And that's what I'm trying to communicate. What I like to do here is communicate how NASA works. Trying to get people to understand how NASA works. It's very annoying when I'm not going to say very annoying. That's not really the right thing to say. I don't do sources say, all right? I don't do that. I don't like doing that. I get told information from people who work in the industry all the frigging time. I'm not going to report it because it's not concrete. I have no way to prove it. And if I'm really going to demonstrate how NASA does things, if I really want to show how it works and really demonstrate a fundamental understanding for how everything works, I don't think that basing what I report and what I say off of what someone told me that I can't tell you who it is I don't think that's. Nah, that's not for me. Now, don't get me wrong. That's journalism 101. I get it. You don't reveal your source, etc., etc. I understand that. Have you been tested recently with that cough? No, I haven't been tested recently with this cough, John. What are you trying to imply? Dude, I talked for 9 hours straight yesterday, all right? My voice is a little messed up from it, okay? I heard you talk about the importance of hard deadlines and concrete goals for SLS for years. It's great to see it happening. That's right, Marmont. I don't do sources say. That doesn't help me. That doesn't help me show you why this stuff happens with NASA. My beef with doing stuff like that. And okay, all right. I don't want to be a stick in the mud. I don't like being that guy. I really don't like talking about people behind their back. I'll be honest with you. I was taught as a kid, if you don't have something good to say about somebody, shut up. All right? But, you know, as what I'm trying to do is teach you guys how NASA works. And when I see somebody write an article that is literally the opposite of, Like, the opposite of what everything that we've learned here, how the funding works, how the engineering works, how the science works, I'm going to call it out. Like, I don't want to be a jerk. Like, I feel, it seems like my hand is forced there. You see it on Twitter, you see it reported in articles that SLS is really expensive, SLS is really expensive, SLS is really expensive. They beat that drum like you would not believe. And the reality, the fact of the matter is that it's really not. It's not expensive at all. Like HIP, you've heard me go off about cost structure. NASA's costs are total costs involved. So you oftentimes people get sticker shock from hearing that SLS costs $1 billion a launch. What they fail to understand is that $1 billion is literally from, hey, let's build a moon rocket all the way to 5, 4, 3, 2, 1, liftoff. And then the mission, and then splashdown and recovery operations after that. You're looking at the entire scope of the project. All right? Everybody makes this kind of logic fallacy that, a total cost involved project is equivalent to, say, oh, I'm charging $40 million for my partially reusable rocket. And don't get me wrong, this isn't a knock at SpaceX. Good on them. NASA should be doing what they're doing. But also at the same time, you can't knock cost structure and compare meters a second to inches. That's not how that works. You can't compare total cost involved to price per launch. PPL to TCI is not that like I said, that's as absurd as comparing meters a second to inches. You're not even using the same calculation. Inches is a measurement of distance. Meters a second is a measurement of acceleration. You like, it's that far off. So when I see something like that, I have to, I feel a very strong obligation to say that that's not what's going on here. SLS seems like it's expensive, but it's really not. Everybody likes to beat that drum, though, because SpaceX, I don't know. So how much does SLS cost just for the rocket, then? Synerd, I don't have any concrete numbers. Are you asking me to estimate or not? We won't know until we actually go and launch it before you get your price tag. That $1 billion is projected, by the way. And if you rope in development costs, the cost structure changes as well. The article said net spring of 2022, but likely summer of 2022. Yeah, Bandit, I'm in the middle of something. We'll get to that other news in a second. So Nova said, the article said spring of 2022, most likely summer of 2022. Yeah, and NASA just literally said this morning that it's going to be February. I lost my train of thought, damn it. So there's okay, all right, let me pick it up. Synerd, okay, yeah. Estimating the cost of SLS. Well, how much was a shuttle stack? The shuttle program was expensive. The cost of a shuttle stack, so that means to put the thing together, put it on the pad and launch it, was about, what was it, like $425 million in 2011. So let's inflation that out. Let's say $500 million for a shuttle stack, which, considering what that thing does, is actually pretty damn reasonable, if you ask me. That's pretty friggin' reasonable. It could be way better. Could be way better. You could probably cut that price in half if you launched it enough. Right? So thinking about the shuttle stack being about 500 million, I would say SLS is somewhere right in there. Somewhere right in that gap. Yeah. 450 to 500, maybe 600 million. Somewhere in there. For, the if you're using price per launch, somewhere around there. It's still expensive. But if you look at PPL scale compared to the scale, if you look at it on a scale with what Falcon 9 can do and what SLS can do, the price, I always say that the price of a rocket scales exponentially. A super heavy launch vehicle is always going to be more expensive. The way to get around those these big moon rockets being so dang expensive is launching it a lot. Because the more you do it, the more you can find ways to optimize it, the more ways you can bring that cost down, right? That's Elon Musk's plan. That's what he wants to do with Starship. You think the first Starship launch is going to cost $2 million? No way. I mean, SpaceX probably isn't going to tell us what it's going to cost, but look at all the construction that's going on at Starbase. You think people are doing that for free? No way. The only way, but if you're going like on a more conventional rocket, like Falcon 9, I guess would be more conventional. Even though, like, even including partial reuse, the price scales exponentially for a bigger rocket, right? So, and SLS's price per launch scales pretty dang well with Falcon 9 in terms of capability. Long story short, SLS is a bigger rocket. It's more expensive. It can do more things, like put things out by the moon. Falcon 9 can't do that. It can do it with small stuff. It can't do it with people on board. See what I'm talking about? Even if you incorporate Falcon Heavy pricing in there, same idea. Yeah, Falcon Heavy is like halfway in between, and it scales. Falcon Heavy actually might be a little bit like good bang for your buck, so it's actually a little better. But it still scales really, really well. Yeah, Kim. And that's what's really annoying, because it's wrong. That's wrong. That's what pisses me off. I go through crazy amounts of time. I mean, freaking ask Brimo how much time I have involved in making sure that I get this stuff right and making sure that I understand it on top of telling you guys what's going on. Dude, it's so much work. But don't get me wrong, I love it. It's not really work. I spend so much time reading about this stuff and so much time understanding how it works so I can communicate it correctly. Because, you know, I'm not trying to pick a bone with NASA or anything. I want to show you guys how cool this stuff is and what it takes to do it. I always say space is hard, but nobody says why space is hard. I want to know why space is difficult, and I want to tell you why space is difficult, so the next time you hear somebody say that at NASA, you understand what they mean. Because there seems to be some kind of breakdown between what NASA says and what people out in the wild, so to speak, get about what they do. This is what I try to communicate. That's where my meal ticket is. So it's very frustrating and it's very annoying when I see someone, you know, just basically report stuff that's blatantly false and basically get away with it. Don't get me wrong, you say whatever you want, you know? Oh, thanks, Dougie. I'm not trying to fit any agenda. Roger, my agenda is space. My agenda is to get you excited and involved in space. That's my goal. That's my stated goal. It's been my stated goal for a decade. Thank you, Hip. Someone's meal ticket is something else. He even sounds boast about it. So what do you expect? It's very annoying, Salty, not seeing someone like. It's been very clear to me at times that. So Eric says a lot of sources say in his articles, and that's fine. I get it. It's journalists. You don't reveal the source. If you have a scoop and you have something that's going to get your articles more traction, do it. I get it. I understand. But I've seen more oftentimes than not that in the substance of the articles, a general lack of understanding for how spaceflight actually works. It's happened more than once, to the point where like this comes up almost every stream, right? We were talking about putting Europa Clipper on SLS, and what was reported by ours at the time was that there were vibration issues with the payload. The point at which Europa Clipper was at when they decided to move it from SLS to Falcon Heavy was way past any vibrational analysis, or what's called an environment analysis of payload. So you have a dynamic environment analysis of payload on the way up. Where that project was well past vibration analysis. I know that information was cherry-picked because I know how NASA's mission structuring goes. It had to have been. The payload had already gone into fabrication. It's past the CDR. There's no way that would have gotten past the CDR. There's not a chance. So CDR is what's called a critical design review. It's where you basically finalize all the blueprints for the thing that you're building. And you figure out all the testing that needs to be done, and you do all the math out with the testing, right? And then when you start building stuff, then you do hardware testing to corroborate your data, your math, basically, right? And then once those two line up, then you're good to go into operational missions. So the CDR is a critical point where you finalize the blueprints. Europa Clipper's passed its CDR, if I'm remembering correctly. There's no way that there shouldn't be any surprises after a CDR. It should then just be about building the hardware, testing the hardware, making sure your math corroborates to what you actually make. Basically, make sure you made exactly what the blueprint says, and then you go. If it was past CDR, an environmental analysis wouldn't be a surprise. That's how I know that's bullcrap. You're cherry picking information. That's what I'm talking about. Dude, that happens all the freaking time, and it drives me up the wall. But once again, I'm not going to say you can and can't report this. You report whatever you want. And guys, I see it literally in every article. You just, the fact that you wouldn't even bother to understand how NASA's mission structuring goes after a project has been funded tells me either A, you have no idea what you're talking about, or B, you cherry-picked information, which is annoying either way. So do you, and it leads me to, like, do you actually know what you're talking about? Like, do you actually know what you're reporting, or are you just saying what some source is whispering in your ear? That's the kind of stuff I'm talking about. And guys, I don't want to sit here and call out every single time that this happens. I'm not doing that. It's a futile exercise because there would be so many. I would literally be sitting here for days. Every space news would be just me doing this, what I'm doing right now.
Discovery, go at throttle up.
I found an article saying that Europa Clipper passed CDR on April 1st, 2021. And when did they switch it, Phil? Hey, Dodo, tier 2 71-month resub. No, it's not that you shouldn't have brought it up, Hip. I'm not upset. I'm just telling you, yeah, dude, he gets some stuff right from time to time. And if I have to say one good thing, Eric's a great writer. He's a very good writer. Very good. The structure of his articles are very, very, very well set up, very well thought out. I can tell. He's a good writer. July 23rd was the SpaceX announcement. There you go. And Phil, that was off the top of my head. Bro. See what I mean? Like, how'd you know that? Why would you report that now? You shouldn't have any surprises past CDR. NASA is very, very explicit about this in their mission structure. Don't get me wrong, you're not susceptible to vibration problems, but anybody that knows anything about the shuttle knows that a lot of payloads on the shuttle were subjected to a very dynamically induced environment. What does that mean in plain English? The shuttle's SRBs vibrate a lot. It's a very violent event because the SRBs are super powerful. A lot of vibrations. Go watch the dash cam footage of a shuttle launch. You see the astronauts are like, that happens. And anybody that knew anything about the shuttle program knows that that's going to happen with even bigger SRBs that are on SLS. You're telling me that got past the CDR? And nobody thought about that? Okay. Yep. All right, sure.
Discovery,
does that sound like NASA to you? Hey, Rep up 18-month resub. I thought they did that because they were excited. I mean, if it was me, Salty, I'd be excited. I'm not going to lie to you. Having astronauts that were on Dragon 2 said the second stage ride was a little rough. I actually said it was pretty smooth. Liquid fuel engines, because they're not nearly as powerful as a solid fuel engine, at least the ones that are on the shuttle in SLS, the vibrations aren't nearly as bad. What's up, Savvy? The moon. Yep, exactly. So, yeah, hip, like I said, I'm just explaining it. I'm not... Dude, I'm past being annoyed about it. The $30 billion thing annoys me even more, but, yeah, it is what it is, man. Hey, Hooded, your stream reminds me of a good old radio broadcast. It's a pleasure listening to you. Hey, thanks, Hooded. Thank you very much. I'm glad you like it. Guys, like, I don't have an axe to grind here. I like all rockets, and I know that's like hard for people to understand because they're friggin' simple-minded nowadays. I'm turning on my air conditioner. It's getting hot in here. That's like is that a hard thing to understand that I like every type of rocket? I don't like. What makes an SRB so powerful compared to liquid engines? The thrust to start, Violent. Yeah, the space shuttle's SRBs make 12,000 kilonewtons of thrust. 12,000 kilonewtons. That's what, 3 million pounds of thrust? So the amount of force that comes out of one of the SRBs is the same amount of force if you had a 3 million pound block of lead on your back. That's the same amount of force being applied there. And there's 2 of them, by the way. And then there's 3 shuttle engines on top of that. That's the power needed to move a freaking 60-ton orbiter into space. Let's get this man an axe to grind. I was doing that in Icarus a second ago. Nobody cared, Salty. Like, thrust is determined by your mass flow rate, m-dot. Mass flow depends on the surface area of the solid fuel burning. That area is insane. Yeah, that has a lot to do with it. SRBs are just physically a bigger engine. Yep. Combustion chamber surface area can change your mass flow rate, which can change thrust output. Yeah. It can even change the impulse, depending on the ambient pressure outside of the nozzle. So when you're up in space, the SRBs actually get a little bit more efficient because the lack of atmosphere can accelerate the gases faster away from the vehicle. So you do get a slight efficiency increase too. But yeah, I digress. That's what I mean about understanding what this stuff does and being able to communicate it. You know, that's what I mean. Do you think if I said that to like, okay, let me rephrase that. How many space journalists out there would understand what I just said? How many of them do you think? Maybe 50%, 60? Yeah, I'd say 70% of them would. A lot of them, probably not. You know, like I could say that to Das. Das would understand what I'm saying. Chris G, Chris B, those guys would get it. Oh yeah, absolutely. Irene Klotz would probably get it. Marcia Smith would probably get it. Bill Harwood would understand what that means. Can I interest you in Sea Dragon? Yeah, right. Thoughts on an SRB with an ablative aerospike nozzle? Why an aerospike, Steinerd? What's the application there? Aerospikes only really make sense if you're doing some type of single stage to orbit application. Other than that, a regular nozzle will do what you need it to do. Well, why? I mean, it's all application based. I mean, an ablative aerospike nozzle SRB could be done. Sure, I'm pretty sure that has been done. If I'm thinking about that correctly, is the Saturn V just as powerful as SLS? Yeah, Atkinson. Yeah, absolutely. I mean, Atkinson, think about it like this, okay? Say I have 2 cars, all right? I have just 2 regular cars, like a Honda Civic and a Toyota Corolla, right? Let's just take 2 random cars, okay? You know, we'll throw in a Tesla in there for good measure, right? You need to move 100 pounds of cargo 500 miles, right? That is going to take a certain amount. Well, in the case of the Corolla, the Tesla actually complicates things a little bit. So just put the Tesla over here for a second. You have a Corolla and a Honda Civic, okay? They each one of them has about the same sized engine. It's a 4-cylinder, it's front wheel drive, 4 doors. Just basically just a regular car, right? You need to move 100 pounds of payload 500 miles, okay? That's going to basically require the same amount of fuel, barring a couple of things here and there, right? Right? It's going to, yeah, I mean, like what? What is it going to cost? Like, I don't know. Each one of those cars gets, what, 30 miles to the gallon? You going 500 miles? So, how many miles? How many gallons of fuel do you need? You need 16 gallons of fuel. Each one of them would get very similar fuel economy on the highway because they're similar vehicles, right? Both of them are up to that task, right? But what if one of them has a 12-gallon fuel tank? It's not going to make it in one shot. You have to refuel, right? If both of them have a 16-gallon fuel tank and they both get 30 miles to the gallon, they're going to make it, right? Atkinson, in space flight, there's no gas station up there, so you got to make it in one shot. So, yeah, the Saturn V and SLS are very comparable, barring a couple of things here and there, right? I think the Saturn V is a little bit more well thought out than SLS is, in terms of its full end-to-end architecture, but that's a different story. But for the most part, they're the same thing, because you need to build a rocket like this big to be able to go that distance. All right. For the nerds, this is the nerd speaks part, Atkinson. Long story short, your rocket needs to be big enough to be able to have enough delta V to be able to get to the lunar surface. That number is not going to change. Just like if you have two cars that are trying to go 500 miles, that 500 mile does not change. All right. There's no point where the destination will just move closer to you, move further away. The moon is a static object, and because spacecraft, this is Atkinson, this is where it gets a little weird. Spacecraft range is not measured in distance. It's not measured like the cars are, okay? Spacecraft range is measured in acceleration. It's all about how fast you can go. So you need a rocket that's able to get to the moon to accelerate to a certain mile per hour, or in meters a second or feet per second. Pick one. Doesn't matter. I'll use meters a second. You need to be able to accelerate something to about 15,000 meters a second, give or take, to be able to get to the surface of the moon. If you do not have a big enough fuel tank, you're not getting there. And keep in mind, rockets can dump parts off so they can become more and more efficient over time, because there's no need for that big Saturn V to get all the way to the surface of the moon. You just need the little lander, right? So, long story short, yes, it is comparable to SLS because both of them have similar destinations. Yeah. Sure. Once again, I think the Saturn V is a little more well thought out. The Saturn V came with a lander built into the design. SLS doesn't. Just yet. Soon, though. Hey, Space Explorers. Whitney, what's up? 28 viewer raid. Thank you very much. Savvy's like, Saturn, good. SRB, bad. Ultraviolet rays, bad. Lotion, good. Yeah, Chris, does that make sense? Yeah, because they have similar destinations, just like the cars have similar destinations. Yeah, they're comparable. Once again, personally, I think the Saturn V is a little bit of a better design. It's a little teeny-weeny bit more capable than SLS is in its current capacity, but it's comparable. Just like a Honda Civic and a Toyota Corolla are not going to be exactly the same thing. All right, one's made by Toyota, the other one's made by Honda. They're two different things. Great, finally back on Twitch. How are you? Très bien. Yeah, I'm fine. I still don't really understand why an SRB is more powerful other than it has more thrust. Why not just make a bigger liquid engine? Well, SRBs are a little bit, yeah, they have one moving part, yeah. Math, you're not wrong. Better is the downfall of good, indeed. Violent, where you literally, like, it's physically a bigger engine. That's what I'm trying to tell you. It's physically bigger. Liquid fuel. So with liquid fuel engines, why not just make a bigger liquid fuel engine? Liquid fuel engines are hard to scale. Okay, the reason why they're hard to scale is because of how the propellant gets moved into the combustion chamber to combust and get turned into happy explosions that come out the bottom. Right? When you have a liquid fuel engine, you have oxidizer, you have propellant. That goes into the engine, and there are pumps. Okay? There are pumps on the engine, and they pump the fuel into the combustion chamber. It mixes in there, blows out the bottom. That becomes exceedingly difficult when you get past a certain scale. Why? You can't turn the pump fast enough. Pump can't deliver the fuel fast enough for a bigger rocket engine. That's actually a problem that they had with the Saturn V first stage engines. Well, it's a little more complicated than that, but generally that's the idea. Liquid fuel engines are hard to scale because you can't, eventually you can't spin something. You're getting to the limits of mechanical engineering right there. That's what makes Raptor so dang good. Raptor, because of how the pumps on it are made, they're actually made using a hydrostatic bearing design. They can achieve much higher RPMs. That's why Raptor that's why Raptor is so good. That's why it's such a good engine. Because I don't think people understand. Raptor engines to like other rocket engines is like what a 707 is to a DC-3. That thing is like, that's the thing that SpaceX, like, that's the gift right there. Starship is just a grain silo without those Raptor engines attached to the bottom, right? Could they strap two turbo pumps on one engine? I mean, most engines have two turbo pumps on them hired, but that's not what you're trying to say. I mean, I suppose you could, but the second, like, if you have one that has slight differential RPM off the other, you're going to screw up your mixture rate. So, hired, what's the solution? If you can't put two turbo pumps on one engine, two oxidizer, two liquid fuel turbo pumps on one engine, what's the solution? Add another engine, and there you go. That's why rockets have clusters of engines, right there. Right? Adding another engine would be better than adding another set of turbo pumps to the engine design. That would really complicate the engine. And then the second that one oxidizer turbo pump is slightly lower than the other oxidizer turbo pump, you're going to get a mixture imbalance in the engine, and the engine shuts off. Yeah. Or it doesn't perform how you think it's going to perform. Stuff gets complicated, dude. You could do it with electric turbo pumps like in the Electron. Yeah, that doesn't scale very well, Far. How did Sea Dragon solve that problem? Big dumb rocket. Pressure. Sea Dragon was relying on pressure feeds, John, not turbo pumps. Pressure fed system. Basically a big balloon with a rocket engine at the bottom. Yep. Yeah, also what Rocket Guy said. It didn't. So it's simpler to have multiple engines than one big engine. Kane, how many rockets do you see have one engine at the bottom? Ares 1 is the only one I can think of, and that didn't go very far, figuratively and literally, right? Falcon 1 did. Yeah, there you go, Falcon 1 as well. When's the last time one of those launched? SpaceX, as soon as they could, they immediately opted for a multiple first stage engine design. How they were trying to overcome that problem, or how Robert Truex was going to overcome that problem with Sea Dragon, is a pressure-fed system. Yeah, pressure-fed. So, Sea Dragon would have had two big frigging balloons of liquid fuel and kerosene, and then they would have relied on the pressure of the fuel tanks to out the bottom. The Lunar Module Ascent Stage has one engine and its SSTO. Synerd, I'm literally losing brain cells every time you talk. We're talking about launch vehicles from Earth. Wrong celestial body. So wait, you're telling me that the launch vehicle architecture on the moon to get stuff into orbit is different than on Earth? Please, tell me more. Okay, that one was on purpose. What you just said is one of the most insanely idiotic things I have ever heard. At no point, Mr. Madison, in your rambling, incoherent response, were you even close to anything that could be considered rational thought. Everyone in this stream is now dumber for having listened to it. I award you no points. And may God have mercy on your soul. Okay, a simple wrong could have done just fine, but... I know you did that on purpose, you jerk. Sorry, I'm not going to pass up a quote to quote Billy Madison. Sorry, I'm not going to pass that up. I divided by 0. Oh yeah, Delta 4 heavy, not heavy. Atlas 5 has one RD-180 in it. I need more coffee. I need more coffee. It's some new render of the launcher light space rocket. Let me see. Oh, hey, that's pretty neat. That's pretty neat. Cool.
Discovery.
Hey, DIA, thank you for the host, buddy. Anyway, before we were derailed by a bunch of winners in chat here, let's see, what were we talking about? Oh yeah, violent. Why are the SRBs, for a number of reasons, you can scale SRBs a little bit better. That's where they come up with a segmenting system. Because the SRB is basically a pipe, right? It's a pipe with a little nozzle at the bottom. Well, not little in the case of SLS's SRBs. Because it's so ridiculously simple, and all of your fuel is technically in your combustion chamber already, you don't have to worry about delivering fuel to that combustion chamber. So you can make it a lot bigger. You can make it way bigger. You can make it 5 segments bigger. That's why the SRBs are a little easier to scale, long story short, because they're a lot simpler. SRBs have one moving part. Some SRBs that fly on the sides of rockets today have 0 moving parts. It's just a spark plug at the top of that pipe. That's it. And if the SRB has 2 moving parts, it's a little nozzle at the bottom so they can gimbal it. Were you trying to think of single-engine lifters? If so, Delta 4 was a single-engine first stage. No, Savvy, no. That's what chat's trying to do because they're, trying to demonstrate that they can contribute to a conversation when in reality they have no idea what they're talking about. I don't freaking know. We were talking about why you wouldn't want 2 turbo pumps on a rocket engine. Why don't you want 2 turbo pumps? Well, it's easier to do multiple engines than it is to do two turbo pumps on a rocket motor. We're talking 2 turbo pumps in the context of 2 oxidizer pumps and 2 liquid fuel pumps. The second you have differential RPM between the 2 turbo pumps, the second you're going to screw with the mixture on the rocket engine. If one of those turbo pumps doesn't work correctly, or if, say, the propellant hits one before the other, you're going to screw up the mixture for a second. I mean, it might stabilize out during ignition, right? But they would need to be synchronized. The RPM would need to be synchronized. So now, how do you fix that? Well, you'd need basically a synchronizer gear. So now we're talking about taking helicopter parts and putting them on a rocket engine. This can get super complicated super fast. Just cluster rocket engines. It's easier. Do you think SpaceX will ever use SRBs, or is it just too incompatible with reuse? Incompatibility with reuse, Capybara. The only way SpaceX would use an SRB is if they would absolutely need it, or if somebody paid them to make something that used an SRB. That's the only way. Why not make SRB rockets instead of liquid then and scale them up? Well, Violent, that's what they wanted to do with... Northrop Grumman wanted to do that with Omega, their Omega rocket. NASA wanted to do it with Ares 1. Ares 1 had a huge, just bigger SRB first stage and a nice hydrolox second stage for a good performance up there, and the SRB gives you good performance down here. They tried to do that. Ares 1 got canned. That's why there's so many people that like Ares 1. Ares 1 is simple. It's a simple design for comparatively for what it is. Your first stage has, let's see, the decoupler at the top. It has reaction control systems for roll control authority. A spark plug and an igniter at the top of the SRB in the top segment, and then you have 2 power units feeding a gimbalable nozzle. It's what, like 4 or 5 moving parts? A first stage with 5 moving parts and a vehicle that can move 25 tons into low Earth orbit? That's pretty good. No, we can't do that. No, we can't do that. It's not safe, right? SRBs cannot be shut down. Not true. Not true. You can inert an SRB. It's been done. It can be done. Apocalypsis. The current strap-on motors that fly right now, or the SRBs that are on the SLS, those don't have inerting systems, but it's possible. Yeah, pump inert gas into the combustion chamber, and you'll lower the combustion chamber pressure sufficiently to get combustion instability, and the thing will flame out. Yeah, it's possible. It works in the same way. You remember the SN9 test when they had what was it? Nitrogen or helium ingestion into the Raptor engine, and it just basically, the flames went all different kinds of colors, and then the thing just freaking hit the ground. Yeah, like that. Same thing. Yeah, put an inert gas in the combustion chamber. You can shut SRBs off. It's possible. You can throttle them too, but that is much more about how you make it. The throttle ability of an SRB is built into the manufacturing. It's literally how you pack the grain inside of the SRB, the shape of it. Because changing the combustion chamber surface area over time, right, can give you a different thrust curve on an SRB. You can have progressive thrust curves where thrust increases over time. You can have regressive thrust curves where thrust decreases over time. The way the grain is packed actually impinges flow and makes the combustion chamber surface area smaller over time. It's physically how you pack the grain inside of the SRB. When you get into segmented SRB design, so where you have one segment on top of another segment on top of another segment on top of another segment, if you can pack each segment in a different shape. And if you do, well, it's going to start burning propellant at the top, and then that propellant's going to shoot out the bottom, and you burn the grain at the top, right? And it goes all the way down, right? The top shape, if it's a different shape, you can vary your combustion chamber surface area, and you can make an SRB that can throttle up, then throttle down, then throttle up, then throttle down again, like the space shuttles did. The space shuttle's SRBs did throttle down for maximum dynamic pressure. So will SLS's. They'll do the same thing. But that was already baked into the design. It would, if you just launched the SRB, a space shuttle SRB just by itself with the nose cone on it, it would still throttle down at that same time. But then it would go back up, then it would go back down, and then it would go back up, etc., etc. The space shuttle SRBs have a very peculiar thrust curve because they have to make up for the fact that there's a space shuttle attached to the side. So they do weird stuff, kind of like this one over here, kind of like that one, kind of like this one. See, different shapes will give you different thrust curves over time. Thank you for linking this. I would say that SRBs are more safe than other engines. I would say that SRBs are more safe than other engines because they're so much more complex, or is that not true? Are you asking me or are you telling me? Would you be able to make a first stage out of nuclear engines? Sure, if you wanted to, Fire. I wouldn't. Nuclear engines are much better used for up there. Remember, nuclear engines are very efficient. You can make them produce a lot of thrust, but efficiency is the name of the game there. Much better used for an upper stage engine. But yeah, of course. Sure, why not? EJ, it's current year. We don't use common sense anymore. Do SRBs have baffles in them? No. There's no injector plate, Fistus. There's no injector plate. It's just a combustion chamber filled with grain inside of it, a throat, and a nozzle. That's it. Literally, it's an Estes rocket engine, only a lot bigger. Any other questions before we move to the next news? Also, look at this picture. That's nice. All right, that's enough SLS for the day. So this is an interesting thing here. If you want to ask Dmitry Rogozin a question about Roscosmos activities, new projects, or international cooperation, you can do it here. Click on Zadadlu? I'm not saying that right. Button and fill out the form. Questions are accepted until October 25th. Check this out. This is the funny part of this. This is why I'm showing you. I have the feeling the most important questions will be ignored, as they always are. You are not right. Please ask most difficult questions. Whoa. Well, you just got told. You got told. I'm sorry, that's very funny to me. So if you guys want to ask Dmitry a question, go and do that. That's the guy that runs the Russian space program. That's him saying, no, ask me anything you want right there. All right, next bit. So actually, okay, yeah, I forgot that this was in the space news. NASA update on its SLS rocket and Orion spacecraft. This is from the meeting this morning. This is Mike Sheets' recap of it. The translation makes that very direct and hilarious. Nope, you're wrong. Yeah, right. But ask normal questions, not meme stuff. I don't know. If I was going to ask Dmitry a question, what would I ask him? Yeah, Rocket, that's a good one. Why was there a ban for Russian space news providers to write content for non-Russian outlets? That's a good question. Rocket Guy, my guess is that somebody was reporting about Russian Ministry of Defense stuff, and that's probably why they did that. They literally ITAR'd somebody. That's my guess. Well, the Russian equivalent of whatever that is. I'd ask about Emur and Soyuz 5 progress. What would I ask him? What's the deal with not launching Russian crew on Dragon? There you go. That's actually a pretty good one. Kim, I'm trying to think. What don't I know? Like, is there something I don't know? See. What is happening with Sea Launch? New NSA design, maybe. Also, when Buran, I'd ask him about that too. Any movement on the acquisition of Buria? Sea Launch is a good question as well. Yeah, that would have been a good one. When Energia too. Savvy, that actually would kind of feed into what I'm getting at. My question, and Kem, maybe I'm not understanding correctly. Obviously, language barrier, and I'm trying to work on that, etc., etc. Mine would be, look, I understand that INSA with Oriol will be used to get to the moon eventually, but like it would be one of those crappy two-part questions that the press always asks, and I hate that question, and I hate stuff like that. But my question would basically be like this, Kim. Look, eventually you're going to need a bigger fairing. It'd be exceedingly difficult to do any type of lunar architecture when you're only using 5-meter fairings. You're going to eventually need to move to either A, a bigger core diameter, or B, a bigger fairing. When and how is that type of stuff going to transpire? And here's the thing, Kim. I would ask that question, and here's the response I would get. We're not that far in the program yet. We don't know how we're going to do that just yet. We're not at that point. This stuff takes time. That's the answer you'd probably get. Are you working on your Russian? Yeah, I'm trying to, Violent. We'll work on it a little bit here in a second. I still can't get over seeing the SLS photos in the VAB. It's pretty rad, isn't it, man?
Hey.
What's up?
I have to leave to go get Mom soon.
Okay.
I was trying to get the aerobed out of where it is, but I'm worried I'm gonna knock over your Lego shuttle. So could you put it in the living room when you have a chance?
Sure.
I love you.
Love you too, baby.
I'm trying not to worry about this airport trip, but I'll be fine.
You'll be all right.
I know, but lost in traffic. That's all I'm gonna say.
It's 7 o'clock. You're not gonna hit traffic.
Google Maps says otherwise.
Okay, don't listen to me. I've only been living here for 3 decades. Whatever. So, yeah, Kem, that would honestly be my question. What's the roadmap? Like, seriously, what's the plan? What's the plan? I want you guys to go to the moon, and I frankly don't give a crap if it's with China. If you want to work with us to go to the moon, that's fine. If you want to work with them to go to the moon, sure. All right, what's the plan? That's honestly what I'd ask. Like, how are you going to do this? Because neither of you are going to get there with Long March 5 and Proton, just like we ain't getting to the moon with Delta IV Heavy or Falcon Heavy. That's not sustainable. You need a bigger rocket, like Starship, like SLS. What's the plan? How are we going to overcome those problems? When full boost back Energia. Actually, Savvy, you know what would be a good idea? Taking the Energia core stage and making it into a lifting body. Yeah. Yeah, so like, think like a Venture Star with a bunch of flyback boosters attached to the sides. That would be very complicated, now that I'm thinking about that. Yeah, we probably shouldn't do that. No, not Buran. I'm not talking about Buran. I'm talking about the Energia core stage. We got full boost back Polius. Ooh. Too soon. Too soon.
Discovery, go
I
and
think
throttle.
they also can just abandon Yenisei and replace it with Nuclon. Yeah, maybe. You know what would be cool? 32 months. Thanks, Geek. I saw Ewok in here earlier, but I was in the middle of something. I forgot to say hi. She called me Yins and everything. You Yins guys is doing good. Vulcan, also, got some more information about your Freedom of Information Act request. Apparently, there is some high-quality Ares 1X footage, though the request did get deferred to Langley. 3D printed fuselage tank structure can make it easier. Yeah, of course. Why lifting body? Extra mass. Just bounce it off the atmosphere around the planet. That's way cooler. She says hi again, all yins. I'm saying hi to all yins here. Rocket Guy, I would probably ask if Roscosmos is looking into their own free flyers like NASA is, and would that lead to their own lunar outpost? Yep. The Soviets did boost back with Polius way before it became popular. Yeah, too soon. Too soon. Anyway, let's keep going here. So this is Mike's recap here. Let's see. NASA is planning to do a wet dress rehearsal early next year before returning to the VAB to do some additional checks before launching. Honeycutt says he's seen the SLS team go through many learning experiences and lessons learned. We've learned a lot about how to put the rocket together, and I think that's gone really, really well. Artemis 1's potential launch windows. Yep, there they are. February 12th, net. Hey, how are you doing? Oh my God, what did you do to your face hair? I got annoyed with the mustache king because I rolled over in bed and I put my face in the pillow and mustache hair went up my nose and it woke me up and I got annoyed and got rid of it. True story. Yep. So you said you were going to work on getting the big SSTO done. Does that mean the clean sheet design is off the table for now? For now. Yes, for now. For now. We're gonna prove out the big SSTO. We're gonna get it working, and then I'm targeting basically the end of this year. That should be the end of this year should be enough time to get the Rapier engines unlocked, or or figure out another architecture if we need to. EJ got rid of it, and then in the middle of the night, or waited till the next morning. It was in the middle of the night, yeah. If you want a more detailed set of SLS launch periods, yeah, there you go. That big SSDO has been in development for almost a year now. No, since May. And I had to kind of pump the brakes on mission mode, guys, because of Route 154 stuff. But don't worry. I'm gonna try to finish strong with mission mode in Q4 of this year. We're already in Q4. Time to deliver, Jim. Yep. Whitmire says there's 3 different ways to look at the cost of Artemis 1 mission and declined to give a number because there are a number of reports right now about what the best number is. I would really refer you back to public. Yeah, okay, we already got it. All right, cool. Let's go over and see what's going on with the Russian news. We already went over that. If you want to hear the meeting in its full, you just go back a little bit in this VOD at the beginning. UCF space jerseys are hitting the field now. Cool. Космодром Восточный. Nope. It's construction crews are working on the launch pad of Angara. Okay. Nice, everyone. That's cool. Hey, nice crane. That really is ogromny Chunguska. Work started in 2020. Hey. Okay. Starting to work on the launch plate. Nice. Сергей?
Проектное положение, 2 составные части. Вообще 01 рама состоит из 16 частей, 4 угловые секции, 4 перрона и 8 средних составных частей. Эту работу мы планируем завершить в планах 5 ноября.
$2,000 tons? They expect to finish installing it on November the 5th. Hey, Dave, what's going on? Holy Rebar? Yeah. You're the VP of the Student Veterans Association. That's cool, man. Last, okay. Someone built the Golden Gate Bridge in Minecraft. Impressive. Most impressive. Ceremony. Year 2020. Last, please. Last. Okay. Wait, you missed this. Wallops supports Department of Defense rocket launches. NASA's Wallops Flight Facility supported the launch of 3 suborbital sounding rockets the evening of October 20th, 2021 for the Navy Strategic Systems Programs and Army Hypersonic Program Office. The high operational tempo for hypersonic flight campaign was executed by Sandia National Laboratories. The test will be used to inform the development of the Navy's conventional prompt strike and Army's long-range hypersonic weapon offensive hypersonic strike capability. Like I said, that's been a thing for a while. It says they delivered it by the Northern Sea Route. The Barents. Yeah, okay. Yeah, I remember now. Yeah, they made the sub-assemblies in the shipyards. Hey. Ooh. Hey. Alright. Cool. Okay, Stars and Galaxies ought to be easy, eh? Yeah, sure. I will add the bullseye to the news. Alright, let's see. What's the next one? Yeah, it's starting to look like a flame trench, dude. It's coming along. Oh, nice, Buck. Sorry, it was AFK. What was that Russian thing? What you were looking at is the Vostochny Cosmodrome's Angar launch site a second ago. The one with all the rebar. They're working on building the pad. Work has been proceeding on the pad since, what is it, 2020? And it should be good to launch in 2022. That was basically launch pad construction. This right here... this is Cosmodrome Vostochny man, this is tough. 2023 to 2024? Yeah, that's probably more accurate. What is this word right here, Kem? What's that one? Sobrani? Sobrali. That was close. Assembled. Sobrali is assembled. Okay, so this is assembly of the Rakety Nosicitel Soyuz T1B. So this is, they're putting together a Soyuz T1B at the Eastern Spaceport. Vostochny. This is them putting one together. What is this one for? OneWeb? Hey, alright. Are the 4 outer boosters universal, or are they made to go in specific positions 1, 2, 3, and 4? Universal hit. OneWeb. Yes. I like how clean everything is. It's cool. Cool. So that just showed them putting together the rocket. That's neat. All right, what else do we got? I recognize the guy in the picture. Spaceflight participants, Japanese entrepreneur Yusaku Maezawa and his assistant Yozo Hirano, continue for preparations for the 20th visiting crew to the ISS. They will go into orbit in December of 2021. The MS-20 spacecraft will be operated by Roscosmos cosmonaut Alexander Misurkin. Alright, let's see what Yusaku's up to. Yes, this is the Dear Moon guy. Hey, Toa.
Участники космического полета из Японии продолжают подготовку к 20-й экспедиции посещения на Международную космическую станцию. В декабре 2021 года на орбиту должны отправиться японский предприниматель Юсаку Маэзава и его помощник Йозо Хирано. Кораблем Союзом С-20 будет управлять космонавт Роскосмоса, герой России Александр Мисуркин. Несмотря на то, что представители Японии полетят на МКС как космические туристы, они должны ознакомиться с устройством корабля Союз МС и российского сегмента МКС, отработать навыки выживания в различных климатогеографических зонах, пройти медико-биологическую подготовку. Тренировки начались в июне, и уже в середине октября участники полета из Японии смогли уверенно продемонстрировать полученные навыки.
Cosmonaut testing. So they're at the Gagarin Cosmonaut Training Center, GCTC, outside of Moscow. GCTC is basically the Russian Johnson Space Center. It's where they do all the cosmonaut training, just like we do all of our astronaut training at Johnson Space Center. Yeah, Star City, is the name of the place, exactly. Mm-hmm. So that's Yusaku Maezawa. So Yusaku Maezawa is I think he's I don't know if he's a billionaire. He might be. He was an art trader. He's an art trader in Japan. He has a lot of money, and he is known for being one of the big investors in Starship. He actually bought a mission on Starship called Dear Moon, which is going to send a bunch of astronauts and poets and a bunch of people on a starship on a circumlunar trajectory sometime this decade. I think Dear Moon was scheduled for like 2023 or 2024 or something like that. So he did that, and he's like once again a huge investor in SpaceX. And relatively recently, after he announced Dear Moon, he announced that he bought 2 seats on Soyuz MS-20 and will fly to the International Space Station with his assistant on a Soyuz craft because he didn't want to wait for Starship. Don't get me wrong, he's still doing Starship things, but he wanted to prepare, in his own words. So, yes, I remember you now, the so-called art dealer. Oh, Father, it's good to see you again. He actually bought a new plane recently, a Global 7500. Father, good to see you got your memory back. What did I do wrong? What did I do wrong, bro? What kind of art do you trade, man? How do I acquire some so I can sell it? Dude, that plane's hooked up. Look at that. Variable AOI on the H-stabs. Not that that's like something crazy, but dude, this plane has an APU in it. Like, dude, that thing is legit. Who bought this plane? Yusaku Maezawa. Dear Moon guy. NFTs, obviously, alright. Do you need different training as a Russian if you want to fly on an American rocket? The training much more pertains to the spacecraft that you're flying on, Violent. Yeah. So yes. Wendover Videos is an amazing video that explains how. Yeah. It's also black. Do you know how much more upkeep they have to have on that aircraft just because it's not a white airplane? I'm serious. Oh yeah, I believe you. Look at the registration on it. It's his initials. November 555 Mike Zulu. You frick, man. What did I do wrong, bro? What did I do freaking wrong? I want a private jet. You know how much easier that would make trips down to Florida for streaming? That'd be so much easier. MZ launched an online shopping platform. He's kind of a local version of Jeff Bezos. Yep. He started selling clothes, it seems. You don't want a private jet. You want a private 747. If we hit the Powerball, Tiggs, I'd do it. So, Toa, you asked what I've been doing. Let me get through the rest of the news, and yeah, we can talk about it from there. I already got the Luna news from yesterday, Kem, but here, last bit of space news here is Tori Bruno reporting the compiled insertion report from the Lucy mission. Atlas V 401 configuration, launching the Lucy mission, the first mission to explore the Trojan asteroids, the 89th Atlas V mission, 100th launch from Complex 41, 260th Centaur mission, launch date selected 30 months ago, launched at window open to the second, high booster performance, very precise injection accuracy, enjoys long walks on the beach. Characteristic injection energy, right angle of ascension, node, and declination. Bullseye, baby. That means they put it where they wanted it to put it. Yeah, that's a good thing. The bullseye means that they said we want the rocket to fly here, and it flew there. Buying space flights. Not one, not two. $73 million plane. He has what I like to call screw you money. Yep. I don't think Powerball money would give you a private 747. On the contrary, Roger, we actually did the math out one time. Yes, it would. Hitting the Powerball at like 500 million, you could literally just spend all that on a 747 crew in maintenance and be able to operate it pretty much scot-free for like 50 years. 747s aren't as expensive as you think they are. Especially an older one. But 747. Yeah, we did the math out once. 500 million would be good, but you'd literally lose a lot of money on that. But you'd be able to operate a 747 for a long time. And this precise insertion cut one Lucy maneuver from the schedule. Cool. Did you account for inflation? I believe we did, Kim. Yes. I remember I did it like we did that for one Space News, and it took me like an hour to figure it out. But yeah, I like went into like how much it costs to hire airplane mechanics, pilots, what like the average pilot's salary is, you know, maintenance on the plane, parts, storage, everything, fuel costs, all of it. Yeah, we did it all out. 500 million would do you right. Yeah, that'd be fine. You could do it. Yeah. Is there a Turo for jumbo jets? Yeah, that'd be kind of... Actually, I bet you there is. Corporations ride share jets all the time. Oh yeah, that happens all the time. Corporations, basically, everybody, like, one Corporation A goes to Corporation B and says, hey, you want to split a 737 business jet? You know, like a timeshare almost. Oh yeah, that happens. Some news from the DARE team. Tomorrow is the final attempt for their launch. We are no-go for the Stratos 4. This is the Delft Aerospace Rocket Engineering. We are no-go and we'll try again for a final slot tomorrow. Unresolved problem with oxidizer filling arm. Team has chosen to cancel today's window in order to preserve our chance for tomorrow. Thank you all for your support. Cool. It must be freaking nice, dude. They had 3 scrubs so far. Sensor on day 1, leak on day 2, and now the filling arm issue on day 3. This is all reflective, Thomas, of very inadequate testing. But then again, it's Delft, it's a university, so that means they're learning, so it's no problem. Here, look at these pictures from EPF Snake. I don't hate what I'm looking at here. I agree, Synerd. Yep. I have 22. Why is the bomb bay open? Man, that thing is cool. What a beast of a freaking plane that is. I wonder how much Maiden's tour with Ed Force One cost. Well, Fuzzilla, they didn't have to pay for a pilot. I know that. Alright. So, Toa, you still here? You want me to give you a status update? You asked what you missed in the last 8 months, so I'm waiting for him to respond. Go, no go. The only reason I ask is because a bunch of people on stream of, like, vast majority of people already know. Like, I've heard this story 1,000 times. Here, we'll look at this picture in the meantime. No, Toa's in here. Doesn't seem that he is. It seems he has gone away. So we don't have to talk about Route 154. I'll tell him later. Heading into the weekend like an autonomous rover on Mars. Yeah, this is a time-lapse shot of Perseverance just doing some four-wheeling, or six-wheeling, I should say. Nice. Hey. Is that helicopter done on Mars? You know what? I haven't heard any updates on Ingenuity. Chat, what say you? You guys know that they did helicopter on Mars, right? Here, in the meantime, we'll just look at more of snakes. Hey. How amazing this that we got video from Mars. Yep, there's a small flight coming up soon. Cool, cool. Okay, Dave, I gotcha. But did you know that they did surgery on a grape? When? When did they do surgery on a grape? Huh? Whoa. Wait a minute. Yeah. 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 Dude. Bruh. I unfold just like the real web. Help teach people about space telescopes by making me a real Lego set. I only need 3.8k more votes to be officially reviewed by Lego Ideas. Bruh. I don't need it, Alex. I definitely don't need it. He got the votes, by the way. It's being reviewed. Most excellent. Here. Yeah, Alex was in there, Whitney. You see that? I don't need it. I don't need it. I definitely don't need it. I need it. Is Alex even here? It's late over there, isn't it? Pinky SpongeBob! SpongeBob Pinky! Pinky SpongeBob! Pinky! Nice. Oh my goodness. If Lego approves it, hopefully they won't have any delays launching it to market. See what you did there. I apologize. It's alright.
Listen, Tranquility Base here. The Eagle has landed.
Check this out. What's that, Bandit? Ooh, a Soyuz Lego spacecraft. That's cool. What is this? Cyclops isn't the leader of the X-Men. He's the supervisor. They rejected that, Thomas. That's a shame. Is Geeson being sus? Alright, is there anything else? I think I got all of it. There's the stuff about the SLS mobile launcher. I haven't heard much else about that. There's launchers renders. We can look at that, and then we should get going. What do you think about NASA's $165 million mission to develop the COSI telescope? I'm not familiar. When is SLS launching? Targeting February 12th, 2022. Some more work I did for Launcher, featuring Launcher Light, a dedicated small-sat vehicle powered by a single launcher engine 2. On its first stage, Launcher Light will deliver satellite payloads up to 150 kilograms. Look at that. Hey. Those are nice renders. I like the truck-mounted TE. That's really cool. The pad used in the renders is 48. Is it?